Okay, good morning, students. Welcome to today's lecture. So, in our last lecture, we had started with the problems on the viscosity. Okay, and we had seen what is Newton's law of viscosity, and we had solved problems on it. So, our next property, which we are going to see, that is called as surface tension. Okay, so first of all, we will see what is surface tension. So surface tension is nothing but the tensile force acting on the plane surface of the liquid in contact with either gas or on the surface between two immiscible liquid, such that the contact behaves like a stretch membrane or membrane under tension. Okay. Now I had just read the definition. First, now we are going to understand what is surface tension. Okay, so in order to understand the surface tension, consider these three cases. This is consider the molecule inside the liquid. Okay, so we are going to consider three cases of molecules. This is molecule one. Okay, so this molecule one or molecule A, it is completely immersed inside the liquid surface. This is molecule B. So this molecule B is near the liquid surface, and a part of this molecule, okay, it is in contact with the air. Okay, and the third case is case C. In case C, the molecules is equally in contact. The molecule is on the liquid surface and it is equally in contact with the air molecules as well as liquid molecules. Okay, now we will see what happens in case A. This is a liquid surface and this is molecule A. Okay, now what happens in molecule A? In case of molecule A, all this molecule A, it is completely surrounding by the same liquid molecules. Okay, now we know in case of liquid or in case of molecules, there are two types of forces that are acting, that is cohesive force, and second is adhesive force. Okay, now what is cohesive force? Cohesive force is nothing but it is a molecular force between same type of molecule. Okay, that means if it is a liquid molecule and the surrounding molecule is also liquid molecule, so whatever the force of attraction between similar type of molecule, that is cohesive force. And adhesive force is nothing but it is a molecular force or force of attraction between different molecules. Okay, that means if this is a liquid molecule and the surrounding molecule is air molecule, okay, so the type of force will be adhesive force. Okay, so in case of case 1 or in case of liquid molecule A, all the surrounding molecules are liquid molecules. Okay, that means suppose this is molecule 1. So suppose this molecule 1 is having cohesive force and it is pulling this molecule in downward direction. So this opposite side molecule, we will call this molecule 2. So this molecule 2 is also having the same cohesive force and it is attracting this molecule in upward direction. And as the molecules are of same material, so these two forces cancels each other. Okay, so basically likewise all the different forces, okay, of cohesive forces of liquid molecules surrounding the given molecule A, they cancels each other. So net cohesive force or net force acting on molecule A, F net, okay, it is 0. Okay, so in case of molecule A, what is happening? All the surrounding molecules, they are applying the equal cohesive forces and they are opposite in direction, so they cancel each other. So no force or no molecular force is acting on molecule A. Okay, so is this understood? Case A. Now we will see case B. Now what is happening in case B? In case B, you can see here 70% of molecule B. Okay, 70% of molecule B it is immersed and 30% of molecule B it is in contact with air. Okay, so here two types of forces are acting. First is cohesive force. Okay, cohesive force, cohesive. Okay, it is acting in downward direction, and second is F adhesive. It is acting in upward direction. Similar is the case in case C. Okay, this liquid molecule on liquid surface, it is 50% in contact with air and 50% it is in contact with liquid. Okay, so here also two type of forces are acting. First is cohesive force acting in downward direction, and second is adhesive force due to liquid and air molecules. It is acting in upward direction. So net force acting on molecule B and C. Okay, F net. Okay, on molecule B or C, B or C. Okay, so this net force acting is nothing but it is a difference of cohesive forces F cohesive in downward direction minus F adhesive in upward direction. Okay, negative sign indicates the direction are different. Okay, so it is a difference between two. Okay, but experimentally it has been found that the cohesive force between liquid and liquid molecules, okay, liquid and liquid molecule, it is greater than the adhesive force between liquid and air molecules or gaseous molecules. Okay, so this cohesive force acting in downward direction, it is greater than the adhesive force which is acting in upward direction. Okay, so whatever this net force acting, its direction will be downward. Okay, so all the liquid molecule on the liquid surface, that means there will be lakhs or crores of liquid molecule on liquid surface, and on each molecule a net downward force is acting. Okay, a net downward force is acting on all the molecules on liquid surface. Okay, now due to this net downward force, each molecule will try to move away from the liquid surface. Okay, अभी उसमें net downward force act हो रहा है, तो basically molecule क्या try करेगा, downward direction में जाने के लिए try करेगा. So as the molecule will try to move in downward direction, okay, and same phenomenon is happening with all the molecules simultaneously. जितने भी molecule है, हर molecule downward direction में move होना चाहता है. Okay, so because of that, on this liquid surface, some tension is created. Okay, on this liquid surface some force or tension that is created on this liquid surface, and that force or that tensile force, okay, because of that the liquid behaves like a stretch membrane, so that force is nothing but surface tension force. Okay, so is this understood what is surface tension force? So surface tension force is nothing but, or surface tension is nothing but, it is a tensile force. Okay, it is a tensile force acting on the surface of the liquid in contact with the gas. Okay, that means on this liquid surface there will be some force which is tension force. Okay, tension force. Okay, and when it will going to happen, when the liquid is in contact with the gas or air, in contact with the gas or air. Okay, on the surface between two immiscible liquids. Okay, now the surface tension force may happen in between liquid or air, or suppose there are two fluids. Okay, suppose this is petrol and this is water. So we know petrol will float on water. Okay, so same type of phenomena happens in between the layer, between petrol, separating layer between petrol and water. Okay, so this may happen in between liquid in contact with the gas or the surface between two immiscible liquid. Okay, so that the contact behaves like a membrane under tension. Okay, so this property or this type of force which is induced on the surface of a liquid, so that is nothing but surface tension. Okay, so again I am repeating the definition. Surface tension is nothing but the tensile force acting on the surface of the liquid in contact with the gas or between the two surface of immiscible liquid. Immiscible means two liquid which cannot be mixed. Okay, जैसे आप water और petrol को mix करोगे तो आपको you will find water settle हो जाएगा bottom में and air will float. Okay, so the mixture of petrol and water, it is an example of immiscible liquid. Okay, so the tensile force acting on such case such that the contact surface behaves like a membrane under tension. So that property is nothing but surface tension. So this surface tension, it is denoted by Greek symbol sigma. Okay, it is denoted by Greek symbol sigma. Okay, now in if you understand the definition of the surface tension, so we can proceed with the derivations of surface tension. Okay, so in your syllabus, you are going to see or you are going to learn the three cases of surface tension. First is surface tension on liquid droplet. Second is surface tension in hollow bubble. And third case is surface tension on liquid jet. Okay, so one by one, we will start with our derivations. Our first case is surface tension on liquid droplet. Okay, so consider any small spherical droplet of liquid, okay, of radius r. Now, on this liquid droplet, on the entire surface, okay, there will be some surface tension sigma which will be acting. Okay, so consider this is a liquid droplet of radius r as shown in the figure, and on this entire surface, okay, on this entire surface, the surface tension sigma, it will be acting. Now we will let sigma is the surface tension acting, P is the pressure inside the liquid. Okay, so let this droplet of liquid, it is cut into two equal halves. Okay, so consider this is one of the half. Okay, as shown in the figure, this is one of the half. So on this liquid surface, this surface tension sigma is acting on this liquid surface. Okay, while inside the liquid droplet, the pressure P is acting. Okay, in opposite direction. Okay, now the surface tension the tensile force due to surface tension acting along the circumference. Now, second type of force that is acting, that is pressure force. So that pressure force is nothing but pressure into area on which is it acting. These two forces should be equal and opposite under equilibrium condition. Okay, so P into pi by 4 d square is nothing but equal to sigma into pi d. Now what we can cancel from both sides? From both sides we can cancel this sigma and we can cancel 1 d. Okay, यहाँ पे d square है, यहाँ पे d है, so 1 d will be cancelled. So we will have the relation. One of the relation is sigma equals to pd by 4, or p equals to sigma by p equals to 4 sigma by d. Okay, so we will have p equals to 4 sigma by d, or d sigma equals to pd by 4. So this is a relation between the pressure force acting and surface tension in case of liquid droplet. So this is our case 1 or derivation 1. After that, our next case is hollow bubble. Hollow bubble is having two surfaces. One is the outer surface and second is inner surface. Okay, so there will be two surfaces which is in contact with air. First is the outermost surface, second is innermost surface. Consider a hollow bubble like soap bubble in air. So it has two contact surface. Okay, one on inside, another outside. So these two surfaces are subjected to two different surface tension. आपका जो total surface tension force है, it will be 2 times. So 2 times sigma into pi d by 2, because there are two surfaces. The pressure है, if P is the pressure inside the hollow bubble, so pressure force will be P into pi by 4 d square. For equilibrium, this P into pi by 4 d square, it should be equals to 2 into sigma into pi d. Again, from both sides we can cancel this pi d with this pi and 1 d square. Okay, so you can say in this case P equals to, you can multiply this here and divide d, so 8 sigma by d, or sigma equals to pd by 8. Okay, P equals to 8 sigma by d, or sigma equals to pd by 8. Then third case is surface tension on liquid jet. Okay, Now consider any liquid jet. Now this liquid jet is nothing but whatever the jet of water coming from pipe. So consider any cylindrical liquid jet as shown in the figure of diameter d and length L. Okay. Now we will cut this liquid jet into two equal half and consider one of the half as shown in the figure. Okay. So it will be a rectangle. On cutting it, it will be a rectangle of two side having distance d and other two side having distance L. Okay. And sigma is the surface tension acting. So the surface tension acting on this, it will be sigma into 2L plus 2D. Okay, perimeter factor and sigma into L plus D plus L plus D. But here D will be very less as compared to L. Okay, so sigma force. Okay, sigma force F is nothing but sigma into perimeter. So perimeter is 2L plus 2D. But here D is very small as compared to L. So हम इसको बोलेंगे simply sigma into 2L. Okay. While the pressure force acting FP. So this FP is nothing but pressure P into area of the rectangle. So area of the rectangle is L into D. L into D. Okay. So basically the pressure force acting, it will be P into area of the jet, which is L into D. So P into L into D. And force acting, surface tension force acting is sigma into 2L plus 2D, but D is very small as compared to L. So it is sigma into 2L. Okay. So equating them for equilibrium, these two force should be equal. So P into L into D, that is nothing but sigma into 2L. So L will cancel from both sides. Okay. So finally we will have P equals to sigma upon आप D को इधर मल्टीप्लाई कर सकते हो. So sigma equals to PD by 2. Sigma equals to PD by 2 or P equals to 2 sigma upon D.